Are you ready? Well, good morning. Voy a hablar en español, aunque la presentación está en inglés. Bueno, también sé que tenemos buenos traductores, así que buenos días. Well, thank you very much for having invited me. I worked in Elegido and I lived in Agua Dulce for a year when I finished my degree, so for me it is a pleasure to be here. I will talk about something which is more general, not so local, and everything we talked about before was really interesting, but I'll move from local to general with a more planet-like vision, in the line of what you just said, thinking in terms of system. The water demand is very extensive and resources are limited. Here in Almería we're very much controlled by that. But the scarcity is increasing, and demand, of course, is going up as well in a very explosive way. When you have a look at what's going to happen in the future, approximately, we see that the water that feeds us and offers food and many ecosystem services in the planet, 30-something percent, 40% of that blue water which is regulated, which is stored in a natural way in an aquifer or in an artificial way in a dam, and the rest would be rain-fed water, so the soil stores it as well and the plant can take advantage of it. And then we're going to see how water in the last century, its consumption was multiplied by 8. If you come to Spain, you see that our numbers or figures are very similar. In the 20th century, population also grew, and with that increase of population, the demand increased as well. Agriculture increased too. In industry, we're talking about energy industry, manufacturing industry, and also the municipal use of water. Until 2010. And then from 2010 to 2050, because the statistics data by OECD and FAO, when these slides are open for you to consult them, you'll see that we have the sources here. It's usually public organizations. It's not my data. And now the contradiction starts. They say that water by 2050 will have increased, the consumption will have increased by 60%. There are areas of water scarcity, and they say that agriculture here is not increasing, so we will have to produce more with less. For me, that means that numbers are not accurate. It says population will continue to increase. It's good to have more children in the world, and we see here, down here, that there is more and more the presence of fresh fruit and vegetables. So there is a lot of future in this, but also meat consumption. Maybe not in Europe, but in places like India and China, who've lived. They have survived with a bowl of rice a day, so they start to want to eat more meat. So even if the increase in population is 25%, the increase in food needed will be 100% in this period, short period from 2015 to 2050. So, meat is very inefficient because I need to have 5 kilos of cereal for 1 kilo of meat. That's why this increase. And this is where it doesn't correspond, because it means an increase in water extractions of 57%. And OECD says no, agriculture will not need more water. So somebody's lying, and you can imagine who is doing that. How are we going to multiply by 2? That the figure is quite scary. The production of food multiplied by 2 in a few years. Engineers, biologists, and we do all have a lot of work with a lot of limitations, because if we apply this curve, you cannot see it very well because I tried to use a lot of information. There is a black line. This is the increase in the production of food. Scientific agronomists and agriculturists and farmers, we every year we've seen how the increase has the food production has increased a kilo by hectare, 100% cumulative. So in these years, 14-15%. So if we have twice the production, that is a success, where fertigation has a lot to say and the better management. But this is business as usual. 50 years with an annual cumulative increase of this 1-2%. There is not much more land or soil to work with. In the next 20-30 years, maybe there will be just a growth of 4%. So that implies that the food we need, or half of it, will be covered by what we call business as usual. And there is a question that I want all of us to answer. This is a real gap, not the gap Antonio was talking about before, the green gap. The real gap is that we're lacking 50% for everybody to eat what they want to eat. Well, another thing would be all just becoming vegetarians. That's another solution. But, like Abel's done. But there are many people who are in their caloric intake limit, and they have to eat at least as much as we do. Apart from that, there is a forecast of GDP increase as well in Asia, Africa. Africa is the continent which has got to grow as well. There are countries which are growing at a 7% rate, and that's good news. That means that the quality of life is improving, and these are this is a forecast for the future. You see what Africa is like. If Africa grows, they wouldn't only want water for irrigation, but also for cities and other technical plants. So the consumption of non-agricultural water will increase as well. So this is a summary. Multiply by 2 the quantity of foods. If you're very optimistic, you would say you can do that with a 5% more water. And FAO is saying we're more realistic, or lacking 57% of water. And energy, information comes from the International Energy Agency. I combined a lot of sources. That would imply an increase of 400% of the water which is being extracted by thermal plants. The increase in urbanization will require an increase in water consumption of 35%, and also the consumption of manufacturers, industry, will imply 140%. So the average would be 60%. Where is that water going to come from? Because what makes things worse, population will be living in areas with under water stress and water scarcity. The future is here, and I'm not talking about 2050. We have to look at today.
And those red dots, and there are some there you cannot see because of the slide, they are places subject to a strong water stress, where there's an over use of the underground water. The green side, you see the water used by farms naturally. In blue we have the artificially added water. But the worrying thing is the orange water. Quite a big percentage of our food is coming from overused aquifers, and that's not 2050. There are brutal aquifer, the Ogada in Kentucky, Nebraska. We've seen of films. There's a large aquifer which is overexploited there, which is used for producing corn and soy, and it is known that in 2 or 3 generations it can run out, and they will have to limit themselves to the renewable water, something similar to what happens in La Mancha. And case of the Cape City, it was a problem. In Seville, there was the issue of evacuating the population at a certain moment, and the same in Cape Town and Governance. In 2015, a lot of water was taken from El Cabo, and the water had been used to water vineyards. And about 40% of the water were used for farming vineyards and not for giving water to people. So these the route is produced once every 400 years. I don't know if it's going to happen, but irregularity is growing and extreme phenomena are ever frequent. Maybe it can happen in the next years. And more than half of the planet is living in areas with hydrological stress, where demand overgrows production, and demand depends on the price. It's not the same demand as price. In the end, you use what you can. I would like to drink 25 beers, but I've only got €3 in my pocket. My demand can be whatever I want, but my final use consumption will be the one I can. So in the end, adjustments are needed, or maybe you can draw from fossil resources, something which is not advisable. And then there's the other side. About 80% of water in China is severely polluted. It cannot be used for drinking. 80%. They have a strong problem. You can laugh on the Mar Menor in Murcia. For 2017, the United Nations says that for 2050, 1.7 billion people will not have access to drinking water. The good news is that we are here, and there's a lot of people, very skillful people, who are ready for this to change. And also from the technical point of view, is that one thing is use, another thing is consumption. Agriculture consumes a lot of what it uses, so at very reduced rates of use, and the average is about when we go down to dosages like these, the return can be about 4 or 5%, but at the level of the planet it's about 40, whereas in other sectors is 80, 95%. So dirty water is coming back. So if you applied all that, even if increase in extraction may be about 50-60%, it is water we send to the atmosphere, and it will come back, but in a different place, just 22%, which is still a lot. And where is water? Let's go on to the practical side. As specialists, we've got a gap, we've got an engineer gap, and we know that there's about 50% of food with which business as usual cannot be covered, and we have done it very well as a species, and also very bad. But where is that water going to come from? When browsing, when reviewing where will water be coming from, it will come from 6 to 7 sources. Reuse of wastewater. This is at least what we see in literature, but you should be critical. This is just a review, just in case I was not time. Desalination, water saving, and updating, which has got limits of its own. Water pricing, Abel also spoke about cost reduction, and there are also limits, of course, reattribution of resources, and in the end you've got to decide on where to use water. I may make a decision where I water, but at the scale of society you've got to establish priorities. And governance. What happened in Cape Town, it was a lack of governance which could have prevented such an awful situation. And also you may see that water, reuse water, that's the overall perspective. The reuse water for me is a source of concern because it's overvalued. When you are in an inland basin, the water, for example, coming from the city of Cordoba, it is reused 3-4 times till it reaches the river. It is reused for irrigation, for many things, for covering the flow. So there's no point in an inland city to reuse water. But it has, there's a point in coastal cities. But then you have the problem of salinization of water. So you've got to be very realistic. When you do calculations on the water you can recover. And desalinization is also got an issue because of boron, for example. Technology is going down, and the estimates I got speak about some 40 cents per cubic meter, and that water will gain access to systems. But there's also a lot to be done. On the other hand, reuse water, you may see a diagram on the left-hand side. I'm not that optimistic. If we want a guarantee as the markets want, control and demand levels should be reached. I don't know if it would be 50 cents or not. It can be even more expensive than desalination. We have a project and we have it with Juan. We'll be working on that in the next few years. Very fast. The truths and lies of modernization. These could take us a full day. First truth, a lot of water is being saved. No, that's not true. The water is in the dam. It is not being used now. That is true. Returns are reduced, but the water is in the dam, which means that our system is more resilient considering the next drought. That's an objective subject. As there's a smallest return, there's no export of nutrients. The nutrients into the system is reduced to about 80% as compared to the prior situation. There's still many salts and nitrogens and elements, but less than before. In the case, Julia hit the nail. If we multiply by 10 the irrigated area, you can save whatever you want, but the increase in the area will eat that up. Second myth, demand is improving. The problem is that it is more vertical in economic terms. As water is more productive now, you're ready to pay more for water. And it's more productive because you decide when and how to use it now. And before you watered when it was your turn, but now you can irrigate your farm when you want. And the conclusions are these: efficiency is very limited. There's a paper published in Agricultural Water Management, and I'll be very happy that you criticize it, because I leave off that. But cost benefit of modernization, it was like 4 to 1. We paid 1 and we earned 4. We gained 4 euros as a community. Water pricing, I think it doesn't work. Elasticity is very rigid, and then we reach the schizophrenia of the European Commission. They said water pricing doesn't work, and they just said that, but then say, but there's no problem. Anyway, apply water pricing. So, and on this I believe it very much. I think it's important that we start talking about water grid. It means network. As we refer to energy grids, we've got to start talking about water grids. And it's a pity that the Tagus River is flowing its water into the sea, whereas in the Segura Basin in the east, they are drying out of thirst. So I think the system should be resilient overall. Well, that's all I had to say. Well, a final remark. Thank you.
Debido al, bueno, lo interesante que son cada